that's the main theme of the conference. So, as you know, machine translation can be used by everyone, and that would be the assimilation, the second method, the second use, which is called gisting to. But for translators, we usually use machine translation for dissemination. So professional translators take the output, maybe, and produce translations to be published. Well, we should also take a look at the other use of machine translation, which already in 2012 by Franz Josef Ochmuth, he was the head of translation at Google, he said, we translate in a day about 1 million books. So, and that's probably higher now. So there's a lot of machine translation being done for regular people, not magic people as translators. But we will, of course, talk about this, about the professional translators. And one thing that comes to mind is that you may have general purpose machine translation. Everyone experiments or experiences general purpose machine translation in the internet, but then there's special purpose. So general purpose tries to address the needs of everyone. So that's hard. It's like you have to please everyone at the same time. That's very hard. So then you have the Googles, the Bing, the Pell, and it's usually free or almost free or supported by ads. It usually cannot meet the needs of every specific translation task because it's trying to please everyone. And it's getting better and better by using co-text. So using the text itself as a context is getting much better translations every day. But still not too much context. It's not so good at the communication context in which the translation will be used. On the other hand, you have task-tuned or special purpose machine translation, which is good at translating text in a specific genre or about a specific project. And that usually comes as a cost because there's actually business. Many companies do adapt machine translation for a particular task. So that's also another possible professional career for translators is to actually be part of machine translation adapting teams. So we have basically a few machine translation technologies available. Most of the machine translation technologies implement very simplified models of translation. The first approximation they do is that machine translation of a text, or translation of a text, is the translation of its sentences, which is a very short-sighted view of the text. So you're just looking at a text in a very local way. But this view is not only found in machine translation, because in computer-aided translation, many computer-aided translation tools just basically focus on the segment, which is like usually a sentence. So this is a big approximation, although there's some progress in document awareness, but still an open field of research. So if you look at machine translation in a compositional way, you basically take your source sentence and you build a representation of this source sentence. And maybe you start with the meanings of words with building blocks, and you use the syntax or the way they're ordered to determine how these meanings are combined into more complex meanings. Then you take this representation and you build a sentence from it. You build a target language sentence. So it's the reverse process. You do everything the other way around. It's funny that this slide, I had this slide from a long time, and the word representation appears here even before neural machine translation was used, and that's the usual word for it. So we're not inventing much. We're just giving the old names to new things, probably. So this is why translators can translate sentences they have never seen. I mean, we as translators can build translations for sentences we have never seen. If I say, let's get the beamer and throw it away through the window, you're going to say, you're crazy, but you understood what I said. You never heard this sentence before. Like a speaker who says, we're gonna tear off the projector and throw it through the window. But you know how to translate this because you know language, and language is compositional. That helps because we can use parts of what we know to do new things. So if you have a crude machine translation model with task-tuned data, so you have a very crude machine translation model, but you still have your data is very much very adapted to your actual task, it may save you time because it may provide quick and affordable raw translations. Usually it doesn't make typographical errors or misspellings, and and it guarantees terminological consistency or not. That's probably, it used to be the case with rule-based machine translation system, as I would say. But now with neural and statistical, it's getting more and more complex. So there are like two big groups of machine translation. On the one hand, that's where I come from, is rule-based machine translation. And on the other hand, is what I would call corpus-based machine translation. So rule-based machine translation, the original method, which was, we still have products like Sistra and Partially and Lucy and ProMT2 and Apertium, they build upwards, so they do word for word, but they just build on top of word for word translation. Hopefully they reach the sentence level. And how do they build these systems? You get translation experts, and they write translation dictionaries and grammar rules. And the knowledge that translators have, which is usually intuitive and non-formalized, has to be formalized into rules that have to be encoded and they have to be computable. So this means that there's a lot of simplifications that are done for the rules to be encodable and computable. If the rules are well chosen, some of them will work fine. And then we have the computer experts just take care of the engine. So it's basically like an agnostic engine that doesn't know anything about the languages, and then the people write about them. So this would be rule-based machine translation. This was the first approach to machine translation. It is still the approach to machine translation when you don't have a corpus, or when you don't have enough of a corpus. Then we have, a little bit about rule-based more. And the systems usually do additional simplifications. Usually you use the transfer approximation. So what the system will do is process parse trees or similar structures, so they do grammar in some way. And the output of rule-based machine translation is usually consistent, so it makes the same mistakes, but it's mechanical. So fluency is not usually something you expect from rule-based machine translation. And also rule-based machine translation has trouble solving ambiguity at many levels. For example, you have lexical ambiguity, like replace can be to put back or to exchange, substitute. Or you can have structural errors like I saw the girl with the telescope. Was she carrying it? Or you were looking at it? So when people do customization, basically you ask experts to write rules and vocabulary for your task. But then we have corpus-based machine translation. In corpus-based machine translation, the system learns to translate a corpus containing tens of thousands, millions, tens of millions of translated sentences. The output can be deceivingly fluent, as Alice said before. It's unfaithful, so you have to be very, very careful when you're post-editing, because you may get a sentence that looks really, really good, but it's not the translation of the sentence you had in the source. So you have two main approaches to machine translation, to corpus-based machine translation. One would be statistical machine translation. In statistical machine translation, which was born in the 90s, what was deployed in the O's, was deployed last decade, we use probabilistic models that are estimated by just counting events on the corpus. Then, since let's say 5 years from now, 5 years ago, a new technology came in, neural machine translation. And this is based on artificial neural networks, which are inspired vaguely on how the human brain learns to generalize. And the problem is that you might not have these big corpora that you need for this available for your language pairs. So for the small language pairs, you still probably have to resort to rule-based or maybe hybrid method. So statistical machine translation, Moses style, Moses is the typical package that people use, basically covers the source with units, so it tries to recognize units. And then some of the units can be one word or multi-word. And then you look them up on a phrase table, you get a bunch of different translations for the unit, you put them together in different orders, and you get the most probable, the most likely translation by using a probability model. So this is one thing about statistical machine translation is that you see pieces of your corpus in your translations. Okay? It doesn't create anything. It just basically, it's a collage. It cuts and pastes the right place. Well, it tries to cut and paste the right pieces into a translation. Already in statistical machine translation, you have this problem of fluency, because there is a language model, a target language model, that tries to make smooth language, fluent language. So sometimes that model will give you a translation that is very fluent, but is sacrificing some adequacy, sacrificing some faithfulness. So, as I said, this is wrong. It says retaken around, sorry, I moved one slide. Sorry about that. Okay. One thing is that your translation looks like your corpus. So if your corpus comes from your customer, your translations will look like what your customer wants, hopefully. Then there is neural machine translation, the new one, the newcomer. Although it was around there for a long time. I was myself involved in the 90s trying to play with neural machine translation, but then we didn't have enough hardware to be able to do this. It's also corpus-based, and you need usually more and cleaner data, as we said. That's the conventional knowledge. The first commercial implementations, I think they appeared in 2016, and it was Google Translate, and then DeepL, and then everyone is embracing it. And it's competitive with statistical machine translation in many applications. Common wisdom says neural machine translation is better than statistical, but I still have to be convinced, because there are not so many measurements. So companies like Alice probably know much better than me how good it is, because it's basically about productivity, and sometimes things are not that easy as just looking at some score. So why is neural machine translation called neural? Why is it called neural? Because it is performed by a software that simulates large network of what we would call artificial neurons, which are very simplified entities. The activation or excitation or activity of a neuron depends on the activation of other neurons and the strength of the connections. Actually, connections can be positive or negative, so it's like when you have friends and enemies. If your enemies are happy, you tend to be sad. If your friends are happy, you tend to be happy. So you can have, and then